Water. It's pretty much everywhere on our planet, right? And yet, getting enough of it sustainably is one of our biggest challenges. In this explainer, we're going to break down the key strategies for managing this precious resource, covering everything you need for your A-level environmental science studies. So let's dive in. So first things first, why do we even need to talk about this? I mean, we live on the blue planet. But here's the catch. The amount of fresh, accessible water is actually incredibly small, and our demand for it just keeps growing and growing. And that brings us to a really crucial question. Why is this stuff we rely on for literally everything becoming a finite, strange resource? It's so easy to just turn on the tap without a second thought. But the system behind that simple action, it's under some serious pressure. Okay, so here's the bottom line. We're using water way faster than nature can top it back up. And you can see this happening all over the world. Take the Colorado River in the USA. It gets used so heavily that a lot of the time it doesn't even reach the sea anymore. And it's not just rivers. Underground, you have these giant water stores called aquifers, like the High Plains Aquifer in the US, and they're being drained at a rate that just can't last. This isn't just a theory, it's got real consequences. But it's not all doom and gloom. The good news is there are clear strategies we can use to tackle this, and they basically fall into two main camps. So let's take a look at the roadmap for how we can get things back on a sustainable track. It all boils down to two core strategies. First, we can get much smarter with the water we already have, using it more economically. And second, we can actually go out and find brand new sources of water. Simple, right? Let's break down what that actually means in practice. Right. Let's kick off with strategy number one, being more efficient. This is all about smart management, conservation, and just, cutting out the waste. It's the efficiency fix. A massive tool in the box for this is water metering. The idea is super simple. Instead of paying a flat rate, you pay for exactly how much water you use. It's a real game changer because it creates this powerful financial incentive. When you see that using less water saves you actual money, people naturally start to conserve a lot more. And of course, technology plays a huge part here. We're talking about all those low water use appliances. You've probably got some at home, like dual flush loos or those low flow shower heads. But it's in areas like farming where this stuff makes a gigantic difference. Switching from old school sprinklers to drip irrigation, which gets water right to the plant's roots, massively cuts down on water that just evaporates into thin air. So, what about recycling? This is where greywater comes into play. It's basically all the used but relatively clean water from your bath, your shower, and your washing machine. Now, you wouldn't want to drink it, obviously, but it's absolutely perfect for things like flushing the toilet or watering the garden. By reusing it, we slash the amount of fresh, perfectly treated drinking water we need for those jobs. All right, so that's the efficiency side of things. Now let's switch gears and look at our second big strategy. If the first one was about managing demand, this one is all about boosting the supply, finding new ways to get more usable water in the first place. And the most straightforward way to do this? Rainwater catchment. It's literally as simple as it sounds. Collecting rainwater from a roof into a tank or a water butt. It's untreated, so it's brilliant for watering the garden or washing the car, and it means you're not dipping into the main supply for those things. Okay, scaling things up a lot, we have new reservoirs. But here's the thing. You can't just build one of these anywhere. Finding the perfect spot is like solving a massive geographical puzzle. You need just the right landscape, a big, steep valley with a narrow exit. The rock underneath has to be impermeable, otherwise all the water would just leak away. And on top of that, you need a huge area to collect rainwater from, with a low risk of pollution. It's a really complex balancing act. Another big-ticket option is an estuary barrage, which is basically a massive dam built across the mouth of a river. And both of these, reservoirs and barrages, come with a big list of pros and cons. Reservoirs mean you have to flood huge areas of land, which causes all sorts of conflicts. Barrages avoid this, but they risk trapping all the pollution from the entire river system right there at the coast. Plus, they can be a massive obstacle for ships. So yeah, there are significant trade-offs with each approach. We can also look underground to what we call unexploited aquifers. These are huge, natural, underground stores of water held in certain types of rock. But again, you can only tap into them where the geology is just right. And the absolutely crucial thing here is the recharge rate. If you pump water out faster than rain can seep down and refill it, you haven't really solved the problem, have you? You've just created an unsustainable mine for water. And finally, we've got the real mega projects. Inter-basin transfers. This is some serious large-scale engineering. We're talking about physically moving massive amounts of water from a river basin that has loads of it to one that's running short. Think enormous pipelines and canals stretching for hundreds of kilometers. It's literally replumbing the country. And this isn't science fiction. These things are very real. A famous example here in the UK is moving water from the much wetter regions of Wales over to cities in England. China has absolutely gigantic projects doing this, and so does Australia. It is a solution, but wow, is it expensive. And as you can probably guess, it can be pretty controversial too. So, we've looked at the two sides of the coin, haven't we? Using what we have more wisely and finding new sources. But the real lasting solution, it's never going to be about picking just one or the other. It's about finding the right mix and creating a smart combined approach. So let's pull all of that together into your complete sustainable water toolkit. On the efficiency side, you've got metering, low water appliances, and greywater recycling. And on the new supply side, rainwater catchment, reservoirs and barrages, new aquifers, and those big inter-basin transfers. That's the whole shebang. And that leaves us with one final big question to think about. When you look at all these different options and you weigh up all the costs and the benefits, what do you think the best combination of strategies would be for a country like the UK? There isn't a single easy answer, but really grappling with that question, well, that's what understanding sustainable water management is all about. Thanks for joining me.